Good day to everyone. So in continuation with the last video to solve the boundary value problems using the finite difference method. So in this video I am going to again solve the two example problems of differential equations using the finite difference method. The first example is, so this is the problem. Solve the boundary value problem of y double prime plus y 5y prime plus 4y which is equal to 1. The boundary values are given at y of 0 equal to 0 and y of 1 is equal to 1 by finite difference method. So you have to use the central difference approximation method with the time step of h is equal to 0.5, and the exact solution is given as y of x is equal to a into e power minus x plus b into e power minus 4x plus 0.25, where the a is having this form and b is equal to minus 0.25 minus a. So we have to also find the magnitude of the error between the exact solution as well as the numerically calculated solution, and we have to find out the percentage of relative error at x is equal to 0.5. Okay, so we have to use the central difference approximation for the both second order as well as the first order. We know the formula. So if you want to find out the solution, so first we write the equation for the second order central difference approximation for equation for the y double prime as well as y prime. So for y double prime we know the values of 1 by h squared of y of I plus 1 minus 2 times of yi plus y of I minus 1 is the central difference approximation method for the second order derivative, and for the first order derivative 1 y prime which is equal to y of I plus 1 minus y of I minus 1 divided by y I minus 1 divided by 2 times of h. So this is the first order derivative for the central difference method, central difference approximation method for the first order derivative. Now we just substitute these two values, these two equations in the main equation, and then we can try to solve it as usual, right? The previous video. Before proceed further, we know the values of h is equal to 0.25, and we have the boundary values of y of 0 equal to 0 and y of 1 is equal to 1, so that we should know how many times we have to integrate this equation just using the formula n is equal to b minus a divided by h. So b value is given as 1 minus 0 divided by h is 0.25, which is equal to 4 again. So n is equal to 4. That means you have to integrate this equation 4 times. For the x values, that means the nodal points at x is equal to 0, we have the value of 0.0, x1 is equal to 0.25, that means increment of x0 plus h, and x2 is equal to x1 plus h at 0.5, x3 is equal to 0.75, and x4 which is equal to 1.0. So for these x values, the given y values are, so the given data values of y of x0 which is equal to 0 and y of x4 which is equal to 1.0. Okay, so these are all the two values, the boundary values which we have given. So that I know we don't know all these values. Now I can substitute these two values for every I value into this equation. So I can get the equation as 1 divided by h squared y of I plus 1 minus 2 times of yi plus y of I minus 1 plus 5 divided by times of 2h, because it's a 5 times of y prime, so that 5 divided by 2h into y of I plus 1 minus y of I minus 1 plus 4 times of yi which is equal to 1. So this is the formula. Now if you try to simplify this formula just substituting the values of h squared, so 1 by h squared 0.25 h squared you will get 0.5. So once you substituted the values of h squared and calculate the final value will be 16 times of y of I plus 1 minus 2 times of y of I plus y of I minus 1 plus 10 times of y of yi plus 1 minus y I minus 1 plus 4yi, which is equal to 1. Or I can just multiply all the constants and constant values and reduce this equation just by collecting the coefficients of yi plus 1, I minus 1 as well as yi. The final value is become 6 times of yi minus 1 minus 28 times of yi plus 26 times of yi plus 1, which is equal to 1. So this is the equation after reducing this equation, just multiplying this constant values into all the yi terms and collecting the coefficients of yi minus 1, yi and yi plus 1. Since we already have the values of the y values of at y of 0 equal to 0 and y of 1 equal to y of x power 4, x of y of x4 is equal to 1. So in between that we need values for x of 0.25, 0.5 and 0.75. That means we need I is equal to 1, I equal to 2 and I equal to 3. So that I can substitute the values of I is equal to 1 and 2 and 3. Then I can after getting this the value coefficients of y, substitute the values whatever we have, then we can find out the unknown values of the y. So for I equal to 1, for I is equal to 1, that means I just substituting the values of I is equal to 1 into this equation, I can get the value as 6 times of y0 minus 28 y1 plus 26 times of y2, which is equal to 1. So I have the initial conditions of the y at x1, which is equal to 0, y of 0 equal to 0, right? So this is the initial values, that means the boundary values which are given, so that I can substitute the values of y0 here. So the final value will be equal to minus 28 times of y1 plus 26 times of y2, which is equal to 1. So this is my first equation since the y0 is 0. Okay. Now I am going to find out for I is equal to 2. I have the solution, which is the x2, which is equal to 0.5. And sorry, this is x1 is equal to not 0. So x1 is equal to 0.25. Okay. And for y equal to 2, we have the x2 value 0.5, but we don't know the any values of this y value, so that I can just substitute I value in this equation. I get 6 times of y1 minus 28 times of y2 plus 26 times of y3, which is equal to 1. So this is my second equation since y1, y2, y3 values are not known yet, so that I can just keep this equation as it is. And for I is equal to 3, that means x3 is equal to 0.75. I have the values of y4, which is equal to 0. So if I substitute I equal to 3 into this equation, 6y2 minus 28 y3 plus 26 times y4, which is equal to 1. And if you substitute the y value, y4 value here into this equation, I get 6y2 minus 28 times of y3, which is equal to 1. So this is my third equation. Now we have the three algebraic equations, equation 1, 2 and 3, so that you can either solve these equations directly, or you can use the Gauss elimination method. Before going to do that, I am going to collect the coefficients of y1, y2, y3 as a matrix. So I can write this as it as minus 28, 26, 0, 6, minus 28 and 26, 0, 6, minus 28. So this is the coefficients of y1, y2 and y3, and in the right hand side we have the values of all 1. Now I can use the Gauss elimination method. So that I can find the values of this y1, y2 and y3. So before doing this, I am going to just write this as the same equation, minus 28, 26, 0, 6 minus 28, 26, 26 minus 0, 6 and minus 28, and so 1, So I can just want to make the values of this first row and first column as 1 or 0, so that I can reduce the equation as for that. So what I'm going to do is I'm going to divide this row 1 by minus 28, so that I can make this first element as minus 1, so that I can just R1 divided by minus 28. So if I done that, I will get the value as this is 1, this is minus 0.92857, and then this is 0, 6 minus 28, 26, 0, 6 minus 28, and this value will be 1 by 1 divided minus 1 divided by minus 28 will be minus 0.03571. This is 1 and 1. Okay. Now I want to make this 6 this is the second row, first column. Sorry, the first column is 0. So that what I am going to do is I am going to just taking this R1 and reduce. R2 is equal to R2 minus 6 R1. So that R2 minus 6 times of R1. By just applying this condition, then my final value of will be 1 minus 0.92857. This will be 0, then minus 22.42858, and this is going to be a 626, then 0, 6 minus 28. This is minus 0.03571, 1.21426, and this is going to be a 1. Okay. Now again I want to make this term as 1, so that I can just divide this element by this value, so that R2 divided by minus 22.42858. If I do this, then I will get the answer as 1 minus 0.92857. This will be 0, this is 1, and this is going to be a minus 1.15924, and 0, 6 minus 28. And this the remaining term, the right hand side term, which I can write here. Now I should make this element as 0, so that what I am going to do is I am going to use the condition R3 minus 6 times of R2. If I use this transformation, I can get the values as 1 minus 0.92850, 0, 1 minus 1.15924, and this is 0, and this is also going to be 0, and this value is minus 21.04456 with a constant value of 0.03571, and this is going to be 0.05414, and this third term 1.32484. Okay, so now I can directly solve this matrix, and then I can find out the coefficients of y1, y2, y3. So that from this last equation I can find out the values of y3, which is equal to 1.32484 divided by minus 21.04456, which is going to be equal to minus 0.06295. And if I substitute the y3 values in any one of this equation, I can get the values of y2, which is equal to minus 0.05414 minus 1.15924 times of 0.06295, which is equal to minus 0.12711. Similarly, I know the values of y2 and y3. I can substitute into the values into the equations where I get the values of y1, which is equal to minus 0.03571 minus 0.92857 times of 0.12711, which is equal to minus 0.15374. Now I have calculated the y1, y2 and as well as y3, Now I'm going to compare this equation solutions into the exact equation. Okay, so we have the exact equation as this: y of x is equal to a into e power minus x, b into e power minus 4x plus 0.25. Value of a, b is given is, so I can just substitute, find out the e power minus 3, and then substitute find out the a value, then substitute it back into this the equation. I can get the b value. So the final values of a and b is, so a is equal to minus 0.70208, and the value of b, which is equal to 0.45208. Okay, so these are all the a and b values, and so we have to find out the values of and then we compare the numerical solution and exact solution at x is equal to 0.5, so that I can find, I know the values of y of 0.5. I mean, at the value of x is equal to 0.5, I have the values of y, which is equal to a into e power minus 0.5 plus b into e power minus 2, which will be equal to 0.11465. So this is my the value of y of 0.5 at x is equal to 0.5. Now I can find the error at x is equal to 0.5, which is equal to, so y2 minus y of 0.5, that is y2 values which I already know, that is minus 0.12711. See what we have identified here, minus this value 0.11465, which is equal to 0.01246. So this is the error at x is equal to 0.5. Now I can find out the percentage of relative error. Which is equal to the numerically calculated value 0.01246 minus analytically calculated value 0.11465 into 100. So that if I do that, then I will get the values of 10.8%. So this is the relative error if I use the time step as h is equal to 0.25. Okay. So now we have calculated the values of y1, y2, y3 unknown values. Then we have compared the numerically calculated value with the analytically calculated solution. Okay, so this is how you can solve the boundary value problems using the finite difference equation. I'm going to solve, discuss one more example. The next problem is, so I have to solve the boundary value problem of 1 plus x squared into y double prime plus 4 into x y prime plus 2y, which is equal to 2, and the boundary values are given as y of 0 equal to 0 and y of 1 is equal to 0.5. By finite difference method, you have to use the central difference approximation for both y double prime as well as y prime with the time step of h is equal to 1 divided by 3. So we have the h is equal to 1 by 3, and the nodal points are x of 0, which is equal to 0, x1, which is equal to 1 by 3, and x2, which is equal to 2 by 3, and x3 is equal to 1. So once if you substitute the central difference approximation method into these equations for y double prime and y prime, we get the equation as 1 divided by h squared of 1 plus xi squared into y of I plus 1 minus 2yi plus yi minus 1 plus 4 times of xi divided by 2h yi plus 1 minus yi minus 1 plus 2y, which is equal to 2 yi, or I can substitute the values of h is equal to 1 by 3 and reduce this equation as 9 times of 1 plus xi squared minus 6 times of xi of yi minus 1 plus 2 minus 18 times of 1 plus xi squared into yi plus just close the bracket, and 9 times of 1 plus xi squared into plus 6 xi y of I plus 1 which is equal to 2. So this is the reduced equation. From this I can just substitute the values of I is equal to 1 and I is equal to 2 because we know the values of x is equal to 0 and x is equal to 1. In between that we have a x1 is equal to 1 by 3 and x is equal to 2 by 3. So you have to find out the solutions at these 2 points. So for I equal to 1, the values given is x1 is equal to 1 divided by 3, y of 0 equal to 0. That is the boundary values which I given. I can directly substitute the values of xi, x1 and y0 in this equation for I equal to 1. So for I equal to 1, I can write this equation as 9 times of 1 plus 1 divided by 9 minus 2 times of y0. So this is my coefficient of y0 plus 2 minus 18 times of 1 plus 1 divided by 9 into y1 plus 9 into 1 plus 1 divided by 9 plus 2 of y2 which is equal to 0. Okay. So or I can just further simplify this equation and reduce the values as minus 18 times of y1 plus 12 times of y2 which is equal to 2. Okay, so this is the first algebraic equation I got. Then for I is equal to 2, x1 is equal to 2 divided by 3 and y3 which is equal to 1 by 2. That is the boundary value for the given for y3. So that I can just substitute to the I equal to 2 into this equation. I can get the equation as 9 into 1 plus 4 divided by 9 minus 4 times of y1 plus 2 minus 18 times of 1 plus 4 divided by 9 into y2 plus 9 times of 1 plus 4 divided by 9 plus 4 y3 which is equal to 2. Okay, so this is also equal to 2. So I can further reduce this equation as 9 times of y1 minus 24 times of y2 which is equal to minus 6.5. So this is equation number 2. Now it's I have only two algebraic equations, so you don't require to go for the Gauss elimination formula. You just reduce this equation. I'm going to just divide this first equation by 2. I can get so 1 divided by 2. I can get minus 9 times of y1 plus 6 times of y2 which is equal to 1, and this value is the 9y1 minus 24 times of y2 is equal to minus 6.5. So I can just directly reduce this equation by just adding these two equations. I can find out the values of y1 and y2. So the y1 value which is equal to 15 divided by 162 which is equal to 0.092592. Similarly, the y2 value which is equal to 49.5 divided by 162 which is equal to 0.30556. So these are all the two values of y1 and as well as y2. Now because we know the values of y0, y1, y2 as well as the y3, so that we can solve this equation for using the finite difference method. So I hope you understand how to implement this finite difference method to solve the boundary value problems. And if you have any doubts, then we can discuss them in the online class. Okay, thank you.